Let's see if I can get this thing back to where I want it. All right. Hopefully you've got your textbook, and we'll gauge this. I mean, I know there were some of you last week didn't have your textbook, so we'll see how you do this week. Hopefully you got a chance to look at the chapter 1 lecture. This one we're going to take chapter 2. We're going to split it into 2 sections. We'll look at the hardware and software piece, and then we'll go on from there. What I want to do here is kind of like, hopefully by the time you're finished this chapter, you understand the components of computer, different types of systems, the way they're used, challenges, trade-offs, things of that nature. Some of this stuff is stuff we'll cover next week. But right now I'm going to look at hardware. And basically the components of a computer hardware is input. They're all devices to help you do the following tasks: to get data in, to input it in, to process the data somehow, to store that data, and then basically retrieve it and be able to output it someplace, whether it's to your screen, whether it's to your to a printer. All of that stuff that's basically what a computer, the hardware components, are meant to do. So if I look at the basic computer, you see there is a CPU that does all the processing. There is a main memory that stores all the different the processes that it's working on. It looks at the input-out devices, CD player, monitor, keyboard, printer. There's both an address bus, which tells me where things are, and a data bus, which how to get data to the different devices, to and from main memory to the CPU to the input-output devices. Now, the central processor unit is, or it can be called a arithmetic logic unit, a control unit, but it has basically an ALU, a control unit, register areas, and the part of the computer that sequences and executes instructions. Now, memory just provides a workspace, working storage to hold the program, instructions, and the data that it's operating on at the one time. And of course, input-output devices end up being data that can, get data to and from those different devices. Now, you may hear the term clock speed, and you can see a lot of terms in this semester. So take a look at, I think I've got the Quizlet link there to help you get some of these terms down. Clock speed basically is just the series of electronic pulses that are at a predetermined rate that attends how fast the machine is going to cycle through each instructions. Today's machines are usually in the gigahertz range, so maybe 2 to 3 to 6 gigahertz, billions of cycles per second. Based on what computer you got, some of the stuff, 1 to 4, I've seen them faster than that, but if you go to Best Buy, you're probably going to find something in that range. Now, the question, you may have heard of multiprocessing. Basically, multiprocessing says I can work on more than one instruction at a time. In a lot of processors, they end up using multiple processors, co-processors, a graphics card to help processing all the data that goes onto a screen. Some of your things you may hear of are like a quad core. There are 4 multiprocessors going on. Co-processors, multi-core processors, 2 or 4 independent processors just working on data together. Now, parallel computing is basically simultaneous execution of the same task. So basically, you've taken a set of instructions or n instructions and you've split it and let it run on multiple processes and then kind of bring it back together. Now, there's some of your fastest computers out there are massive parallel processing system where the systems of thousands of processors working in parallel. And then, of course, you get things that are called grid computing. Now, like I said, these are a lot of terms, and basically it's a collection of computers that work in a coordinated manner to solve a common problem. Forecasting the weather, doing some major calculations on who knows. Now, as far as your memory is concerned, basically you've got main memory and you got storage capacity. Now, main memory is it's the memory that provides the CPU a working storage area for all data. And it is some of your fastest data that allows to keep up with the CPU. And then you've got storage capacity, and that's data that stores information. Now, you may hear the term bytes, megabytes, kilobytes, gigabytes, terabytes. A byte is basically 8 bits, and a bit is just a 0 or 1 to represent a single character of data. And then it's how often, how many of them are you stringing together? Is it 1,000 bytes, 1,000,000 bytes, 1,000,000,000 bytes, so on and so forth. Then, as you can tell, you can probably now, most of your computers are probably getting in gigabyte range. Some of the newer ones are starting to put things in the terabyte range as far as what you can buy. Now, RAM is random access memory. It is temporary, and it says it's volatile. Volatile just means that when I turn off power, it goes away. So it is constantly changing, and if I turn off the power, it disappears. Now, what kind of types of RAMs? There are static RAM, so they're used for high-speed registers and caches. They're dynamic RAM, that's basically used for main memory. Sometimes you got a double rate synchronous dynamic RAM access memory, but it's basically just faster RAM. Now, there are other forms of RAM, and based on which computer you're buying, you're going to be told, it's going to tell you what kind of RAM is it getting. And it basically says, hey, I'm trying to reduce the amount of energy it requires to run things running. And if there's some data out there called read-only memory, that is non-volatile. Basically, it does not change when the power goes off. So it's kind of permanent storage. So when the power goes off, you still have everything you need. Now, storage devices. Now, granted, that stores large amounts of data, instructions, information. Advantages over memory, they don't change, so it's non-volatile. So you shut the power off, everything stays. You got a whole lot more capacity, and usually they are cheaper, and you can store a whole lot more data on them. Now, secondary storage is not directly accessible to the CPU. So you have to have what they commonly use as input-output channels to access the secondary storage and transfer that data into immediate areas that can be accessed by the CPU. You've got some common forms. You've got magnetic, which is really not common anymore. Optical and solid state are the ones you're seeing. Now, a lot of your new computers are coming with solid state secondary. Your optical would be your CD. Now, here you just get a rough idea of magnetic tape. It's a sequential secondary storage. Storing backups for critical organization data, but mag tape is, I can't remember the last time we've backed anything up to a magnetic tape. I'm not sure the school has a tape drive. A hard disk drive, all your computers have disk drives for direct access from the storage. Virtual tape. Now, this is storage that is not as needed as frequently. Now, there are definitely some optional secondary storages, and it ususes lasers to read and write. Those would be your CDs, DVDs, video discs, Blu-ray, things of that nature. What's becoming more and more common is your solid-state devices. It stores data in memory chips rather than magnetic or optical. It definitely requires less power, provides faster access, has no moving parts so it doesn't break like a hard drive can. Most of you probably have a solid-state drive. That's what your USB is. But now a lot of the new laptops and things are starting to come with solid-state drives on it because of the lower power, faster access, so your systems boot a whole lot faster. Now, for big businesses and stuff, they've got large secondary storage. They'll have data centers that store a lot of data, and some of the formula, they'll use storage area networks. They'll have networks of disk drives to be able to store and retrieve all their data. Or they'll use what we're commonly use is cloud computing storage. Now, so what is a storage area network? Basically, it is a high-speed special purpose network that integrates all your data. So now it offers a lot of different features and capabilities. It allows you to disk mirror, which means I can put the same information on two different places for fault redundance. So I can, if I lose something, I've got a backup for it. You can use it for data backup and restore. You can archive data. You can migrate from one storage device to another. So it just makes easier and more flexibility to protect the information that you want to store. Rough idea of what a storage area network looks like. I'll let you look at that on the PowerPoint slide. Now, sometimes you're getting companies out there offering storage as a service or cloud-based services, and all of us have Google Drive, Dropbox, OneNote, OneDrive. All those things are cloud-based services. That means I can put something out in the cloud and get to it from any device that has the software to do it. Now, input-output devices, they basically what? Allow me to get data in and out of my computer. Now, a lot of organizations want to make sure that these input-out devices, they need to make sure they select which ones to make sure it matches the business goals that they have in mind. Because you want to make sure your input device is accurate and fast. Your output devices, you want to make sure they're timely. And sometimes you can get specialized, functions if you need to. Now, from some other input devices, the common ones used for keyboard, mouse, speech recognition, motion sensing, scanning devices, optical readers, a lot of those. Czechs are now starting to use some of the magnetic ink so that, guess what? You can take a picture when you're doing automatic deposits and stuff. Other devices, I'm not going to go through them all, but as you can see, there are a lot of different ones that we use a lot day to day. RFID tag. Whoops, one too many. Displays. Now, there are different types of displays, how to put output to computer, and based on how much money you want to spend, a lot of them are different uses. LED, LCD, plasma, and you probably recognize those a lot from different advertising on TVs and how they're done. Printers and plotters. Most of the printers we got are either inkjet or laser. Plotters are basically larger printers, and they usually I shouldn't say usually. I've seen both laser and inkjet on a larger scale that I can do big 3D, not 3D, but very large drawings, blueprints, machine layouts, things of that nature, schematics and drawings for buildings. 3D printers. If any of you have picked up a mask from the college, one of the face shields, we did the framing with our 3D printers, and basically it just uses plastic to build a device based on what design you put. You give it a three-dimensional design, and they load the practice in it. And here you see an example of something actually printed in hand with a 3D printer. General purpose machines, there are definitely a couple of different types. There are single user and multi-user computers. Single user, also you got mobile, sorry, your smartphones, laptops, tablets are all fall into this mobile. You can pretty much take it anywhere you want to go and have access. Some of them have access to Wi-Fi. Some of them will let you go to use your telephone system, Sprint or AT&T system if you've paid for that feature on your laptop or your iPad tablets. We've all seen those. Now, sometimes you're going to see things called, we know what desktops are. They're just bigger than our laptop. The ones in the classroom that you're in is a desktop. But you could have something, a workstation, a little bit more powerful. Thin clients is if we were using a service like VMware, which allows me to software create computers, then all I need is a device that handles my internal, external devices. So keyboards, monitors, mouses, your mouse that you'd use, and it really has no really moving parts. It just has all the I/O components connected to it. I don't know if I've got an example. I'll see if I got an example I can show in class. Now you're talking about on the big end of computers, you've got servers, mainframes, and supercomputers. A server is just a computer that's employed for a specific task. Internet, printers, network options, just any kind of special feature you want to do. The advantage of these, they're scalable. I can make them as big or as small as I need them. Now, a mainframe is a larger power that's used by some companies, and supercomputers are the most computer, the fastest, and there's only a few in the world. But there are some problems that need to be resolved that require that kind of horsepower. Another brief section here is, and since we have a couple of data centers in the area, and I guess you can call them server farms. Whoops, one too many. Basically, a server farm is what? It's a room used that holds a large number of servers. And access to this is controlled and authorized, by your login password and what you've paid for. Virtual server, did I miss a section? Yeah, I guess not. Virtual server is basically a method of logically dividing up resources versus a physical division. So here is a representative of what a virtual machine like VMware would use, where I've got a hypervisor that actually communicates to the physical equipment and create three logical machines that can be accessed. Now, data center is basically, if you go up, 321 to Google, or you go north to 321, or you can go south to Apple. They've both got climate-controlled set of buildings that have computer hardware delivers data for all of us. Now, factors that are driving this is what? Demand for needing more storage, additional storage needed, just more processing. I need to distribute my access securely across the country, so I need to have distributed data centers so that I'm not just put all my eggs in one basket. So if my data center goes down, I could lose. Of course, benefited is definitely a whole lot easier to build one large building, and that way I can control energy and processing and cooling. You can make them strong enough to absorb the impact of a disaster, whether it's hurricanes, based on what you're trying to do. If you're in Florida right now, you want to make sure you handle the hurricanes. Lately, earthquakes. So we're hoping that the Google's data center up north handles the earthquakes we've had recently. Green computer is basically a program considered to be efficient and environmentally responsible in just the whole way they run their business. So they're making sure they reduce the amount of hazardous material. It allows companies to lower their power costs, enables safe and disposal and recycling of equipment they use. Whoops, I had one too many. And then you got electronic product environment assessment tool, and that's just a system that allows people that are buying equipment to evaluate and compare different electronic products across 51 different types of environmental commander. So if you're into green computing, you may want to use this tool to be able to evaluate how good your vendor is. So hopefully it gives you a brief idea on hardware in this section, and I look forward to seeing you in class. Have a nice day. Bye-bye.